Chapter 14, Cosmology, the study of the whole universe, the whole enchilada. I like this little marble triangle I found on PowerPoint. The pattern there in the marble actually reminds me quite a bit of what the universe looks like on the largest scales, which is where we start in this chapter. We're going to go through the Big Bang Theory and dark energy and everything. First of all, let's look at the evidence for the universe on the largest scale. There is no overall structure. You don't find something like you would with our galaxy where you end up with a big spiral structure. What we know is that the universe seems to be homogeneous in every direction that we look. And we saw this in the last chapter when they did the Hubble Deep Field in 95 and again in 97 and then in the 2000s. And everywhere we look, we see pretty much the same thing, thousands and thousands of galaxies. And so on the biggest scale, we said that it really begins to look like a cobweb where you have strands of galaxy clusters and immense voids in between. We call this isotropic. When you have the same number of galaxies in any direction that you look. And that has a hugely profound consequence that we'll talk about in the next section when we get to Hubble's law. The fact that the universe looks the same in every direction gives us a clue to the nature of the universe itself. First, let's look at what this looks like. So here we have going out 750 megaparsecs, so billions of light years. And look at this. In one just particular direction, you have 11,000 galaxies, and in another direction, you have 12,000 galaxies, so it's pretty close there. And you're starting to see this cobweb work itself out on these very largest scales. I thought this was interesting. The National Radio Astronomy Observatory in 2007 found a particularly large void. I haven't heard much about it since then. But it was so large that they thought it actually didn't quite fit the pattern that they expected, but kind of interesting. So let's recap where we are. We have planet Earth here in our solar system, the third planet from the sun, and our sun has its stellar neighborhood, which is on an arm called the Orion Arm of our Milky Way galaxy, a large spiral galaxy. Our galaxy is in the local group of galaxies, which includes our sort of big sister galaxy Andromeda, and a whole lot of little dwarf galaxies and irregular galaxies. But our local group is part of an even larger cluster of clusters called a supercluster. We're part of the Virgo supercluster, which includes the Virgo cluster, which is a very large cluster of galaxies. And then our Virgo supercluster has other clusters around it. And so if you could have a quote-unquote God's eye view of the universe, it would tend to look something like this. That's where that cobweb comes in and the strands and so forth. That's the part of the universe that we can see. And remember, we can only see out kind of in a bubble of time that goes out 13.8 billion years. That's as far as we can see. The universe is actually much, much larger than that. But the light from those more distant galaxies, it literally hasn't had time to get here yet. Which is why we were kind of limited our horizon of what we can see. But astronomers estimate the entire universe at this point may be, in the neighborhood of 100 billion light years across at this point. Now, I'm actually going to cut this lecture and make it very short because there is a fantastic website that I want you to check out. I'm going to have my classes do this today. Called The Scale of the Universe. If you just Google search for Scale of the Universe, it is incredible, and it allows you to use a sliding bar to go down to the very, very smallest thing imaginable, the quantum foam that we think underlies the very smallest scales possible, right on up to the size of the observable universe, and you have complete control, and everything's going up by scales of 10. It's magnificent. It is absolutely incredible. You can go up through nebulae and galaxies and galaxy clusters and the whole thing. So I strongly suggest there's a link on the iTunes U site here. I'll put a link on Edmodo as well. Try out that, and we'll talk about this next section next time. Thanks for listening.